This lesson is all about plane analytic geometry. So a lot of things that will be discussed under this topic pertains to the Cartesian coordinate system. So that would be all about points, lines, in particular, straight lines for today. Straight lines, straight parallel lines, perpendicular lines, the conic section, and especially the Cartesian coordinate system. So the very difference of this one with your plane geometry is that this would be all about the coordinates, the coordinate system. So we'll be using a lot your x and y coordinates and the Cartesian coordinate system itself. So to give you a little background or a little review about your Cartesian coordinate system, so that's a rectangular system, and for today we will be using the two-dimensional system. So you have your x and y axis here, and you have your different quadrants. We call this our quadrant 1. This is our quadrant 2, quadrant 3, and you have your quadrant 4 here. Okay, and this is your positive x-axis. This one is your negative x-axis, the positive y-axis, and the negative y-axis down here below. Okay, and when naming a point or when identifying a point, let's say the point is here, we use your coordinates. Coordinates are your x and y, x comma y. Okay, these are your coordinates. So the x coordinate is called your abscissa, and your y coordinate is called the ordinate. We sometimes call this the ordered pair. Okay, so we use these coordinates or the ordered pair in identifying the point, in locating the point. So as we would know if it is in quadrant 1 or quadrant 2 or quadrant 3 or quadrant 4 respectively. So in this case, if your point is in quadrant 1, you should expect that the x coordinate is positive and also the y coordinate is positive, right? In quadrant 2, the x-coordinate here is negative, but the y-coordinate is positive. In quadrant 3, say we have a point here, negative x-coordinate, and you also have a negative y-coordinate here. And lastly, for quadrant 4, we have the abscissa x-coordinate positive, and then we have negative ordinate or the y coordinate. Right? So that's the basic that we need to know so that we could identify or we could at least plot the points that we will be encountering for today's lesson. Alright? So a lot of the things or a lot of the other formulas that will be encountered about this topic, I would just insert it along the way as we solve our sample problems. For our problem 1, we have find the distance between 2 points P1 with coordinates 8, 2 and P2 with coordinates 5, 6. So we need to find the distance between 2 points. Okay, so if you are to plot that one, and we have 8, 2. Let's just say we have 1, 2, 3, 4, 5, 6, 7, 8. And this one is 1, 2, 3, 4, 5, 6. So basically, both of them are in the first quadrant because x is positive and y is also positive. So 8 comma 2 is this point here. And you have 5 comma 6 is this point here. Okay, so what we are to find here is the shortest distance between these 2 points, or basically this line here. Right? So our distance formula employs the use of our Pythagorean concept. Okay? So we need to find the distance between y and then distance between x. And if we already know that distance by Pythagorean, you can compute your distance formula d. Or simply saying, you can use your distance formula, the square root of x squared minus x sub 2 minus x sub 1 squared. So that's basically the difference in your x values. So that would mean this distance, right? And then you need to add that one to the difference between your y values, y sub 2 minus y sub 1 squared. So you need to get this distance here. And taking the square root of that would give you this distance d by Pythagorean theorem. So in this case, you can set your x1 and x2, y1 and y2. So either way, you will land into the same answer if you will set this as with subscript 1, or you will have this and you will have this as with subscript 2. So having said that, we can substitute all our values directly. X sub 2 is 5 minus x sub 1 is 8 squared plus y sub 2 is 6 minus y sub 1 is 2 squared. So that distance is the square root of, we have here 5 minus 8 is negative 3 squared plus 6 minus 4 is 4. 6 minus 2 is 4 squared. So this becomes square root of 9 plus 16. D is the square root of 25. And square root of 25 is 5 units. So the distance between P1 and P2 is equal to 5 units. It's our first formula to get familiar with our distance formula. Problem 2, find the midpoint between the given points. P1 with coordinate given, you have 7, 4, and P2, we have 1, negative 2. So what is unknown here is the midpoint. Okay, so how do we get our midpoint? So say we have here a line. Let's exaggerate this line. And say this line contains 2 points. Say this one here is 2, 0. And this one is 4, 0. You know that the midpoint, by just looking at this values here, the midpoint is 3, 0. And if you are to play with the coordinates here, how will you be able to arrive to 3 given that you have 2 and 4? Okay, is it right to say that 3 can be obtained by adding 2 and 4, then dividing it by 2? That gives you 3, and that 3 is here. So with that being said, we can get our midpoint M by getting the x coordinates, x1 plus x2, just like what we did here, and then you need to divide it by 2. And then comma, you have y1 here plus y2. You also have to divide that by 2. It's that simple to get the midpoint. Okay, so now we get our x1 and x2. Let's have this as 1 and this values as our subscript 2. We have 7 plus 1 divided by 2, comma, 4 plus negative 2 divided by 2. Okay. So this becomes 8 over 2, and this becomes 4 minus 2 is 2 over 2. So our midpoint final answer would be 4, 1. Right? 8 over 2 is 4, 2 over 2 is 1. This is our midpoint. The middle point between the two points given. Alright. For problems 3 and 4, we will be talking about segment extension and division. Alright, extension and division. And the basic knowledge that you would need to answer this type of problem are your ratio and proportion and distance formula. Okay? So number 3, a segment 5, comma 11 and negative 3, comma negative 1 is to be divided into 4 equal parts. Find the point of division nearest to 5, comma 11. So we have here 2 points. Maybe we could at least draw them. Alright, so we have 5, comma 11, let's say around here. That's 5, comma 11, and we have negative 3. Negative 3 is over here, and negative 1. 3, negative 1. So, with these 2 points, we can form a line segment. Okay, those are your terminal points. And we need to divide these segments into 4 equal parts. So, that would be a point here, maybe another point here, and another point here. The question is, what is the coordinate of this point nearest to 5, comma 11? And how do we approach this problem, right? What you need to get here is the total change in x, right? The total change in x and the total change in y. Okay, how do we get the change in x? What do we have? x2 minus x1. So that if this is our x2 and this is our x1, what do we have here is 5 minus negative 3. So that would mean 8 units of displacement from this point to this point with respect to x. We do the same for y. That would be y2 minus y1 is equal to 11 minus negative 1. And that would mean 12 units of displacement along y. Pababa naman siya dito. Okay? So, going downwards. And as you can see, that x division and y division is, that x displacement and y displacement is being divided into these 3 points here. Okay? So, 1, 2, 3, 4. 4 drops for y. Right? So, every drop kay y, every increment dito would mean 12 divided by 4. Right? So, y increment is 12 divided by 4 kasi 4 parts ang division na nangyari dito. And that would be 3 units pababa with respect to 5, 11. For x increment naman, okay, every, ayan, maliliit na drops dito ng x, every ganito would mean 8 over 4, that is 2 units siya papunta sa left. Again, with respect to our 511 yan. So, ibig sabihin, 2 units ito na movement, another 2 units dyan, another 2 units, another 2 units, and finally, pupunta siya sa negative 3, negative 1 na point natin. So, if we are looking for this point, what we have to do here is, let's name it as point A. This is your point A. What you can do to get the coordinate of that is, you have this 5, and we are going to the left. Since going to the left tayo, nagma-minus tayo, no? From a positive 5, pumupunta tayo sa left, we're going to the negative side. So that would mean minus your increment. So that is 5 minus 2 units na increment to the left. Ang y naman niya is 11. And since we're going downwards again, that's another minus. Minus 3. That would be the coordinate of point A, which is unknown. This is 3, and this would be 11 minus 3 is 8. Okay. That is our final answer for problem 3. If problem 3 talks about segment division, problem 4 talks about segment extension. So, the segment from negative 1, 4 to 2, negative 2 is extended 3 times its own length. Find the terminal points on both sides. Now, let's just have it on both sides. So, let me draw your Cartesian xy, and we have 2 points given. We have negative 1, 4. Let's have it somewhere here. Negative 1, 4. Okay, a little closer. Negative 1, 4, and another point is 2, positive 2, negative 2. 2, negative 2. Okay, so if we are to connect this one, this would be our segment. And the problem says that this segment would be extended 3 times. Extended 3 times on both ends. So basically, we have another line here that is 3 times as much as this one, and that will have a point here. Let's say this is point A, and we have another extension onto this side 3 times, which is 3 times again of this line here. That would be our point B. And what we are tasked to do is to get the coordinates of points A and B. And for all the things that relates to segment extension and segment division, what I always do is to get the change in X from the original points that are given and the change in Y. That's similar to what we did with problem 3. So this is x2 minus x1, and this is y2 minus y1. So that x2 minus x1, let me erase a little portion of this. This one is x2, let's just say this is x2, negative 1 minus 2, and that is equal to negative 3, right? And we have here this one is 4 minus negative 2 this would be equal to 6. Alright, so there's a movement 6 units to this point, and we have 3 units along X. Okay? So, kung meron tayong 3 units along X and 6 units along Y, therefore, if i-multiply mo siya by 3, kasi the extension is thrice. Extended 3 times. Right? The problem told us na extended 3 times. And we are to get the terminal points. So, ayun na nga. Kung extended 3 times siya, i-multiply natin ang increment, ang change natin by 3. So that the increment natin kay x would be equal to 3 times 3. Okay? Di ko na lang muna i-consider yung negative sign dito para distance lang muna ang kukunin natin. No? 9 siya. So, naka-absolute value lang muna tayo. And this would be 3 times 6 units. And that is 80. So, para hindi tayo maguluhan, everything that is going to the right would be positive, and everything that is going above our original point would be positive as well. Otherwise, magiging negative yun. So, considering our PA, dito natin siya i-refer because this is the point nearest to PA. So, that is 2, yung original x niya. And from this position, papunta tayo sa right going to PA. So, that's plus on the x side. So, mag-add tayo ngayon ng 9 because that's the increment na expected natin. And then, negative 2 ang kanyang y and it's going down. So, that's a minus na y. So, this is negative 18. So, that our final PA coordinate would be 11, negative 20. That's one of the terminal points that we are looking for. Okay? And then going to PB naman, what we have here is, this one is the nearest point to PB, negative 1. And then PB is going to the left. So that would mean negative ang magiging effect nitong 9. From this point going to the left, mas magiging lalong negative ang x value natin. And we have positive 4 and going up from this position to the y-axis, through the y-axis, going up tayo. So that's a positive 18. So that PB has this coordinate negative 10, 22. Yan. So that's how you do segment extension and division. Problem 5. This talks about centroids. Centroid and area by coordinates. Alright. So basically, kung plane geometry kasi yung pinag-uusapan natin, we get the area of our figures using the sides and the angles. But for analytic geometry, we will be using coordinates to do that one. So, problem 5 asks us to find the centroid and the area of the polygon bounded by these points. Negative 5, 4. We have 1, negative 4, 0, negative 4, and lastly we have 4, 5. Alright, so the first thing that we need to do is to plot these points so that we would know how it is located on our Cartesian coordinate plane. So this is xy, and let's put some incremental ticks here. Okay, positive y, positive x, negative x. Negative 5, 4 is somewhere here. We have 1, negative 4. 0, negative 4. So they're close to each other. If I'm not mistaken, it's here. 0, negative 4, And then we have 4, 5. 4, 5. You might be asking, Ma'am, can we solve this problem without actually plotting the points? You can solve the centroid without plotting the points, but when it comes to area by coordinates, it is really necessary to at least identify where the points are located. Alright? Kasi a lot of times, nakashuffle kasi itong points na to. And when we compute, there's a certain direction that we follow. I'll show you in our computation. So, centroid is basically the center of this one. The center by coordinates. Alright? So, when we get our centroid, it is, we can get that by averaging method. So, that the centroid C is the summation of x, okay, divided by the number of coordinates. And then, this one is the summation of y divided by the number of coordinates. That's as simple as that. So that for centroid, you have here negative 5 plus 1 plus 0 plus 4 divided by 4 coordinates in total. And for y, you have 4 plus negative 4 plus negative 4 again plus 5 divided by 4, and that would give you your y coordinate for centroid. Okay, for x coordinate first, negative 5 plus 1 is negative 4. Right? Negative 4 plus 4 is 0. So this is 0 over 4. And this one is 4 positive minus negative 4 is 0. You have negative 4 here plus 5, that is 1 over 4. So our centroid is located at 0, 1/4 coordinate. So that is around here and here. This is your point C, or the centroid of the figure. So that's how you get your centroid. So kahit marami ka pang coordinates na binigay, average ang magiging value ng centroid. The average x and the average y value siya. And when we compute for area naman, since connected siya kay problem number 5, let me erase this one now. Balikan nyo lang yung video if in case medyo naguluhan kayo. But centroid is again all about the average of our x coordinates and y coordinates. So for area by coordinates naman, this is the matrix that we will follow. Area is 1/2 the absolute value of our x sub 1, x sub 2, x sub 1, y sub 1, x sub 2, y sub 2, x sub 3, y sub 3, x sub 4, y sub 4, and then you go back with x sub 1, y sub 1, and take the absolute value again. Okay? So, hanggang x sub 4 lang ako dito kasi 4 na points lang yung meron. But if marami ka pang points na binigay, say 6 or 7, i-extend mo lang siya. And what you need to remember is, i-repeat mo yung una mong sinulat. And, nasa clockwise direction tayo. We follow the clockwise direction. So, ibig sabihin, hindi ka randomly magse-select ng x1, x2, x3, x4 dito. Okay? I-select mo siya or i-arrange mo siya in a clockwise direction. So, if dito ka magsisimula, pag ganito ang arrangement ng points mo. Okay? Eh kung dito ka na magsimula, clockwise direction talaga siya. So, let's try to start dito kay 4, 5 natin. This would be 1/2. Lagay kong ganyan. 4, 5. And then we have 1, negative 4. And then 0, negative 4. And then you have negative 5, 4. Then write again the first coordinate na sinulat mo na 4, 5. Alright, ganyan ang magiging itsura niya. And take note ulit ha, you can only verify na naka-clockwise arrange siya kapag sinusulat mo siya sa Cartesian coordinate system. So that's one thing that you need to remember kasi a lot of students nagkakamali sa ganyan kasi dire-diretso nila itong nilalagay tapos hindi pala siya naka-arrange. So after doing that one, magwi-weave na tayo ngayon. Yung upward, naalala nyo pa siguro tong ganito, no? Upward minus downward weaving tayo. So that this would become 1/2 of the absolute value of upward tayo. 5 times 1 is 5. Negative 4 times 0, you add it, that's 0. Then 4, negative 4 times negative 5 is positive 20. And then negative 4 ito, I'm sorry, parang nag-overlap na siya. Negative, positive 4 pala to. Okay, this is an arrow pala. Positive 4 to positive 4 is plus 16. Tapos, ima-minus mo siya ngayon sa lahat ng downward natin. So, you have 4 times negative 4 is negative 16. And then, 1 times negative 4 is negative 4. You have here, 0 times 4 is 0. And then, you have negative 5 times 5 is negative 25. Then, we take the absolute value of that. So, computing the first part for the upper weaving, that's 5 plus 20 plus 16 is 41. We have 1/2 of the absolute value of 41 minus, this one is negative 16 minus 4 minus 25 is 45. Negative 45. Okay. So, 41 plus 45 is 86 divided by 2. That would give us an area of 43 square units. This is our final answer for area. Okay, that's how it is to solve area by coordinates. So, you cannot only use this under plane analytic geometry, but also under the surveying topics of civil engineering students for area of land by coordinates. Okay, for the next set of problems, we will be talking about equations of the line. Equation of the line, the very essential and basic topic about plane analytic geometry. Number 6, determine the equation of the line that passes, whose slope is 3/5 and passes through 3, negative 1. So we need to get the equation of the line with slope m equal to 3/5. Okay, and we have a point 1 with coordinates 3, 1. So before we proceed with our computation, let me remind you of the details that we have here. The slope is a very important ingredient in getting the equation of the line. So the slope is a measure of steepness. Okay, ano yung steepness? Kung gaano katarik, di ba? So halimbawa, may ganyan kang line, may pahiga, such time na ganito siya. So this one is steeper than this, and than this. So may mga ganun, no? May mga times din na vertical line siya. So ang changes in the steepness of this one is measured or is parang being designated by this slope. And slope natin is nakukuha natin yan by the change in y or the rise over the run. The change in y over the change in x, or basically that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which I think familiar naman kayo, no? Kasi this is one of the very, very basic formula for analytic geometry. But if not, at least you have an overview here. So that's how you use that. And for equation of the line, we have different types of problem. One is meron tayong point slope. Now, this is a point slope na binigay sa atin. Merong isang point and merong isang slope na binigay. And for point slope na mga type of problem, this is the formula that you will use. Y minus y sub 1 is equal to the slope times x minus x sub 1. Alright? So y is y, and y sub 1 is the y coordinate of the point given, that's 1. Slope is 3/5. And we have x minus 3. So let's distribute our 3/5. This would be y minus 1, 3/5 x minus 9/5. Okay, let's multiply both sides by 5 to get rid of our denominator here. Multiply natin siya ngayon by 5 lahat, and that would give us 5y minus 1. Baka no, 5y minus 5 pala, 5y minus 5 is equal to 3x minus 9. Rearranging that would give us 3x minus 5y minus 4 equal to 0. Right? On the other side, 5y, to the other side. Alright. So this is the equation of the line. I hope that is clear. And naintindihan niyo sana, no? That's very easy naman. Okay. Then, for number 8, number 7 natin, this is almost similar to this one, but hindi na siya point slope. Okay? I'll just put emphasis sa ating point slope na formula. May isang point, may isang slope na binigay. Let me erase this one, and so we can proceed to problem 7. Okay. Number 7, determine the equation of the line that passes through these points given. Say P1 is negative 2, 4. And we have P2 here, which is equal to 2, 8. Okay? You have 2 points and you are to get the equation of the line. So, if number 6 is about point slope, this one is 2 points given naman. For 2 points given, you can still actually use this y1, y minus y1, m, x minus x1. Nga lang, kailangan mo isolve muna ang slope of the line. And for slope, paano yun? The change in y over the change in x, or that's y2 minus y1 over x2 minus x1. So, all number 1 coordinates are nandito kay point 1 and all number 2 kay nakay point 2. So, we have y sub 2 is 8 minus y sub 1 is 4 divided by x sub 2 is 2 minus negative 2. So that would give us 8 minus 4 is 4. And you have 2 minus negative 2 is still 4. And that is equal to 1. So upon getting the slope, you can proceed to parang point slope na siya ngayon na form. Alright? So you can use either one of these points given as the points na gagamitin mo dito. But to be uniform with our x1, y1 designation here, we'll just use this point 1. But again, kahit saan sa kanila would yield to the same answer. So you have y minus y1 of 4 is equal to 1 na slope x minus x sub 1 negative 2. That is y minus 4 is equal to x plus 2. So lipat ko to sa kabilang side, you have y is equal to x plus 6. So, pwede mo siyang i-express into this form, and we call this form y equals mx plus b as our slope-intercept form. Yan. Slope-intercept form ang tawag sa kanya because from the way it is written, you can get or you can see directly y equals mx plus b. You can see directly the slope, which is m, and the intercept, y-intercept, which is your b. That's why it's called slope-intercept form. Moving forward to problem 8. Determine the equation of the line that passes through point 4, 1 and parallel to, this is for the first question, parallel to 3x minus 4y equals 7. And letter B question is perpendicular to 2x plus 3y is equal to 5. So we actually have a point here and a line. And from this line, we can actually obtain our slope by transforming it first to our y equals mx plus b form. Y equals mx plus b. So for letter A, we transform that first, negative 4y onto this side, and I will move 3x onto the other side. Then we have plus 7. Dividing all sides by negative 4 would give us y equals 3/4 x plus minus, okay, minus 7/4. So in this case, you can see a slope equal to 3/4. And if we talk about parallel lines, no, parallel lines have the same slope. Parallel lines have the same slope. Same slope, okay? So with that being said, if we are to find a line parallel to this one, and if this line has a slope of 3/4, then the line that we are looking for will also have a slope equal to 3/4 as it passes through point 4, 1. So going back to our point slope form, y minus y sub 1 is equal to m times x minus x sub 1. You have y minus 1, it's y sub 1, slope is 3/4, x minus 4. Alright, so we cross multiply this one onto this side to remove our, to remove our denominator. So this becomes 4y minus 4 is equal to 3x minus 12. Rearranging that would give us 3x minus 4y, negative 4 onto the other side, that's negative 12 plus 4, that's negative 8 equal to 0. So this is the line that is parallel to 3x minus 4y equals 7 passing to point 4, negative, 0.4, 1. For letter B, this one is perpendicular to this 2x plus 3y equals 5. So first things first is we need to identify the slope of this line. So transforming that to slope-intercept form, 3y is equal to negative 2x onto the other side plus 5. Okay, dividing both sides by 3 to eliminate the numerical coefficient, we have y is equal to negative 2 over 3x plus 5 over 3. So that's it. Slope of this line is negative 2/3. And if parallel lines have the same slope, perpendicular lines, okay, perpendicular lines, their slopes would be negative reciprocal. Okay, and if that is negative reciprocal, instead of using m as negative 2/3, the slope of the line that we are looking for is negative reciprocal of this one. So it becomes positive 3/2, and still it passes through point 4, 1. So using our point slope formula again, y minus y1 equals m times x minus x1. You have y minus y1 of 1, m is 3/2, x minus x1 of 4. Cross multiplying this again, this would be 2y minus 2, 3x minus 12. Alright, so to finish this up, this would be 3x minus 2y onto the other side. Negative 12 plus 2 on this side is negative 10, equal to 0. This is the answer that we are looking for the line perpendicular to 2x plus 3y equals 5. Problem 9, distance of a point and a line. We have this problem, find the distance from your line 4x plus 3y minus 12 to 0.5 negative 1. Minus 12 equals to 0 to point with coordinates 5, negative 1. So, ganito yung mangyayari sa problem na yan. We have this line and we have a certain point here. Say that point has coordinate x sub o, y sub o. And this line is in the form ax plus by plus c is equal to 0. We are to find this distance here. This is the shortest distance between this point and this line. That is distance d. And for us to get that, we have a formula na madali namang gamitin for a point and a line. So that distance d is the absolute value of a x sub o plus b y sub o plus c. That's the absolute value divided by the square root of a squared plus b squared. Distance of a point and a line. So what we need to do is, again, take the absolute value. A natin is 4. X sub o is 5. Plus b is 3. And y sub o negative 1. And finally, our c is negative 12. Don't forget, be careful when you copy the numbers. Don't forget the sign. And this is the square root of a natin again is 4 squared plus 3, which is b squared. So that gives us, on the top side, that would be the absolute value of 20. Let me write that one first. 20 minus 3 minus 12. And this one here is square root of 16 plus 9. So 20 minus 3 minus 12 is 5. And this one is square root of 25. So this is 5 over 5. And that means the distance between the point given and the line given is 1 unit. Okay, as simple as that one. Problem number 10, we need to find the distance between two parallel lines, x plus 3y minus 5 and 2x plus 6y equals 21. So we have line 1, x plus 3y equals negative 5. We have line 2, this is 2x plus 6y is equal to 21. Okay, so what happens here is dalawang parallel lines sila. And di ba we know that pag parallel lines, pareho ang slope. So this is in the form ax plus by plus c1 equals 0. And this is ax plus by plus c2 is equal to 0. And this distance d is what we are looking for in that problem. So, syempre, di ba, kapag parallel line siya, dapat pareho yung slope nila. So, that means, kailangan mong i-remember that A and B of both lines are the same. So, the same siya dapat. Alright? So, dito in this case kasi, ang A nito is 1 and ang B nito is 3. So, if i-rewrite natin siya into another form, no, into this general form natin, x plus 3y plus 5 is equal to 0 siya. Ito naman is, mapapansin nyo, hindi pa siya kasi nakasimplify. Naka 2x and 6y pa tayo. So, ngayon, i-move ko muna siya, yung 21 to the other side para general form. 2x plus 6y minus 21 equal to 0. So, kailangan natin gawin is i-simplify natin ito by dividing all the terms by 2. And that would give us x plus 3y minus 21 over 2, or that is 10.5 is equal to 0. So, in that case, makikita nyo na pareho na yung A and B values nila. A and B values nila dyan. Kasi yun yung kailangan natin para gumana yung formula for this type of problem. And ano daw yung formula? C1 minus C2 is equal to the square root over A squared plus B squared. So, distance between two parallel lines, the absolute value of C1 minus C2 over square root of A squared plus B squared. So, in that case, tingnan natin ano yung C1. C1 natin is 5. C2 naman natin is negative 10.5. And A natin dito is, ilan yan? A is 1, tapos square natin, and B is 3 squared. So, our distance would then be equal to 5 minus 10.5 is 4.5. Negative 4.5, pero naka-absolute value tayo, di ba? And 4.5 is 11 over 2. 11 over 2 divided by 1 squared is 1. 3 squared is 9. That would be the square root of 10. Right? So, we have 11 over 2 square root of 10. Okay. Ilan ba ang square root of 10? This would be 11 over 2 times square root of 10 is square root of 10 lang pa rin siya, di ba? Okay. So, ganun lang pala. Hindi na natin siya ma-simplify. So, what we need to do is rationalize na lang square root of 10. So that our final distance value is 11 square root of 10 divided by 20. Kasi 2 times this square root of 10 and square root of 10, this would become 10 times 2. That would be 20. Okay? Or you can have your answer in decimal din. Huh? That would be... How much would that be in decimal? 1.74. I'll just write it here na lang ha. 1.74 units. So, that is your final answer. Distance formula sa ating two parallel lines.